Okay, so I'm going to do a series, the full series parallel here that's right out of your module. So this is probably the hardest series parallel you're going to get. Obviously, they go through and build you up to this one. This is, again, number 3 right out of your Objective 1 exercise. So I'll break this down for you guys just to kind of see what's happening. So here's the original circuit. We've got our ohmic values of all of our resistors and give me a supply of 120 volts. So now we got to find, the question is asking you for our total, the volt drops across each resistor. It's going to ask you the current going through them, so we kind of got to find out the voltage and current going through each one of these resistors. So the first thing we got to do is find our total. And then we can use our source voltage and we can find our total current and then work our way back. Okay, so here's the original circuit. This would be step 1. And unfortunately, I don't know a shorter way to do these. This is probably this is definitely the sure way to get it right. Again, I don't think there's a faster way. This is probably good to have a better understanding anyways. So first thing we want to do is look at these circuits and see, is there anything in series or parallel that we can kind of deal with right off the bat. So R1 and R2 are in parallel with each other, so we can add those up inversely and combine them into one resistive value. Again, we want to total all these up to get our R total. So the first step would be combining R1 and R2. So we would redraw that, draw another resistor here, still have our point, can go to R4, point, R5, and then back to our positive. And then we're still going to have R3 cross all of this here. So this is still R4 at 18 ohms. This is still R3 at 72. And this is still R5 at 200 ohms. Now this guy's going to be different because this is a combination between these guys added parallel. So when we add them in parallel, we add them inversely. So 1 over 180 plus 1 over 120 and then 1 over that whole answer. Okay, a faster way to do it in your calculator is to just go use this inverse button, so it's the second function off the pi, or the x to the -1. So if I take my value of 180 and I go second function pi on my calculator, again it's just the inverse button. So mine is right there. It's kind of not focusing in on here. Let me see if I can get it to focus in. Nope, apparently I cannot. There's my pants. So anyways, there you can kind of see it's x to the -1. So it might not be the same on your calculator, but that's what we want to get at. Okay, so when we go back to the question here, what I would do is go 180 inverse, so to the -1, plus the other resistive value of 120. So 120, second function pi, gives it to me as an inverse. Then I hit equals, and then you have to inverse this as well too. So then I go second function pi to the answer, hit equals, and my total for that is 72 ohms. Okay, hopefully that didn't blow your doors clean off, but this would be the combination of R1 and R2, and it equals 72 ohms. Okay, so that's kind of the first step. Again, I can break down, let's just flip over here, I'll do it quick, 180. So what we were doing was saying basically that the inverse, so 1 over 180 plus 1 over 120, and then 1 over that is going to give us our total when we add them in parallel. Okay, so that gives us 72. So you can type it into your calculator that way too. Either way, just make sure you get it right. Okay, so that's just the inversing portion of that. The next step, so that was step 1, so step 2. Now we can combine this and this resistor because they're in series with each other. Okay? Not this one too, because this parallel is going to affect this group first. So we just look at what's in series with each other. So I'm going to combine these into one resistor now. So we got one big resistor there, got our dot, got our R5, and then we're going to have R3 in parallel with that. So now this guy is going to be R1, R2, and R4 together, and he's going to be, now when we're in series we just add them up straight, so it's 72 plus 18, so we're going to get 90 ohms there. This R3 is still 72 ohms, and this R5 is still 200 ohms. Okay, so that's step 2. Now we can see for step 3, we have this value, and this value that are in parallel with each other. So again, if I take my calculator and go, it's 72 and 90. So if I go 90 second function pi plus 72 second function pi equals second function pi, and I get 40. Okay, so now I have a combination here that's going to be this resistor. Now that's going to be a combination of these. So this guy's going to be R1, R2, R4, and then now R3. And that's a total of 40 ohms. And then we're across to R5 still. So this is R5, and he's still 200 ohms. So now we can add these guys in series because they're in series with each other. So my last step, step 4, is going to be the total combination of all the resistance, so my R total, and it's going to be this plus this, which is 240 ohms of resistance. So my R total is equal to 240 ohms. Okay, sorry, we'll show that there. Okay, so all I did was add this ohmic value and this ohmic value because they're in series, and that's how I got my total. Now to find the current going through, I just take my R total, just using Ohm's law, and my source voltage of 120 volts. So I'm just going to put it up here to find the current. I'll use a different color. So if I go here, I'm going to go 120 volts divided by 240 ohms, and it's going to give me 0.5 of an amp. Okay, so that's the total current going through this whole circuit. Now, the question wants you to basically say, well, what's the current at R5? What's the current at R1? All that kind of stuff. What's the volt drops at these things? Okay, so now we got to kind of start from the back and work our way up. Okay, so we're going to start here at the last step. Again, we found that this ohmic value total here, this R total, was 240. So I know the current going through here, so I at this point is going to equal 0.5 amps. Okay, and if we wanted to put the voltage there, obviously it's at, my V is at 120 volts. Okay, damn, that's blurry. There, oh shit, sorry. That's way better. Okay, so now when we move our way back, we have to keep the theory of series and parallel in mind as we go back through here. So these questions are good because they test your theory on series and parallel, basically on Kirchhoff's law. So when we go back now up to this area, we know that we have the series circuit. In series, the thing that is common to everything is current. We have different volt drops, just like if you put a bunch of light bulbs in series, they get dimmer, right? So I know if I'm in a series circuit, the current, so I'm splitting this resistor into two series, I know that the current's going to be the same through each of them. So I'm going to see 0.5 amps here and here. Okay, and what that's going to do is allow me to also get the volt drop at these positions. And again, the volt drops in series would have to add up to the total. That's a Kirchhoff's law. So the first volt drop I can find is for R5, and I'm going to use Ohm's law to find that. So if I'm looking for voltage, I'm just going to take my current times my resistance, so 200 times 0.5, and I will get 100 volts. So that's the volt drop across R5. Okay, the current again, 0.5, voltage 100 volts. Now over here, I have 40 as my total resistance for all these combination of resistors, but we need to know the volt drop here so we can keep moving forward. Okay, so I'm going to look at the current and the ohmic value, and I'm going to multiply those. Or technically, I could use Kirchhoff's law and say, well, I know there's 120. If this is 100, this has to be 20 volts. Okay, because they have to add up. But if we want to see, obviously it's not too terrible of a calculation, but we'll start slow here. So 40 times 0.5, and it is 20 volts. Okay, so now I've found the volt drop and the current for each one of these. So I could come up here, R5, and write 100 volts, 0.5. Okay, it's going to be the same all the way up to the top. This is what we need to find out here. This is where we're going to start breaking these down and find out the individual current and volt drops through each one. So again, this guy is kind of a moot point now because we've got him taken care of, but he's still there. But we want to kind of just look now at this parallel section. So if I know I got 20 volts, 0.5 amps going through all of these resistors, now I'm going to go and look at this parallel section. Well, in parallel, I know that the voltage is the same and my currents are going to be different. So this is the voltage, this 20 volts is what's going through this resistor, so that's also what's going through both of these. So I know that this has 20 volts here and this has 20 volts here. Now that I know that there's 20 there, and again we could continue to write this here, this is 100 volts here. I know now I have a voltage and I have a ohmic value. I can find the current at each one of these places. So if I want to find the current, I'm going to go 20, using Ohm's law again, 20 divided by 72. So 20 divided by 72, and I get 0.2777. So for my current here, I get 0.2777, or we'll call it 778 amps. Okay. Now I can find out what the what the current is up here as well using this ohmic value. So I'm going to say, in this case, it's going to be still our voltage of 20 divided by 90 ohms, and I get a current here of 0.222 amps. Okay, so now we have all the values for R3. We have the volt drop, we have the ohmic value, and we have the current going through R3. So R3 and R5 are now complete because we know this is 0.5 amps here because that's what it was down here as well. Okay, so now we move back up to step 1 here. We can carry these numbers through again. So again, R5, this guy here is going to be 0.5 amps and still 100 volts. Okay, so that part's done. We know R3 is 20 volts at 0.2778 amps. So now we need to worry about, we have values for this resistor here, 20 volts and 0.222 amps. Now we're going to split those up into these two series portions. So again, when we're talking series, we know that current is the same. So when we split this current for these two series resistors, we're going to give them the same value of current because they are in series. So that means they're going to have a different volt drop. So we can find those again by just using Ohm's law, and we go take our current 0.222 times 18, and we get a volt drop of 3.9, now we'll call that 4 volts, I guess. So 4 volts here, and then 0.222 times 72 equals 16. Okay, and the reason I'm rounding up is just prove a point about Kirchhoff's law here. So again, we had 20 volts here. This is the resistor that we're breaking down into two series resistors now. So this is the total voltage now. So I have to make sure that this and this add up to this, which they do. So 16 plus 4 is 20 volts. So now I have all the values for R4. 18 ohms, 0.222 amps, and 4 volts going through that. Now, last step, go back up to the original circuit here. Again, we could write this guy's at 100 volts. We know R4 is at 4 volts. R3 is at 20 volts. And then we can have currents in here too. So 0.5 amps here. R3, we have 0.2778 amps. R4, we just found out was 0.222 amps. So now we're kind of back to this parallel section here, which is the combination right here of R1 and R2. We know there's 16 volts and 0.22 amps going through both of those. So when we split them in parallel, again, the voltage stays the same. So we got 16 volts here, and we got 16 volts here. So we can find the different current values, and we just take our 16 divided by 180, and that gives us a current of 0.0889 amps. And then here we got 16 volts divided by 120, and we get 0.1333 amps here. Okay, so that's kind of the long and short of it. Long, I'd say, more than short. But that's the total currents we're going to see through the whole circuit. Then the breakdown of the voltage and current for each portion of the circuit. Again, fairly lengthy thing to do. Probably the hardest thing you did in first year. Revisiting it now, probably not fresh by any means, but do your best, go through that. If you have questions on that, let me know. I'll post this to the class.